Hey guys, I'm here with another video from LLM 0 to 100 series. In this video, I want to continue and finish what I started in RAG-GPT. So in that video, I talked about 3 different RAG techniques, 1 from Langchain and 2 from Llama-Index, and we ended up using Langchain for designing our chatbot. However, I mentioned that at some point, I want to test and evaluate Llama-Index techniques and see how effective they are. Well, I did it and the results are very interesting, so I want to just share them with you. But besides just telling you which technique was better than the other one in my testing pipeline, I want to answer 2 main questions in this video. 1, when I want to start a RAG project, what technique should I choose? And 2, how can I evaluate it? And my emphasis will be on these 2 frameworks, Langchain and Llama-Index, because in my opinion, they are becoming the industry standard techniques. And you can already see that they are being adopted by many big firms such as Google, Microsoft, and so many others. And more importantly, these 2 frameworks have effective and good techniques. So if you decide to design your RAG system with one of these 2 frameworks, most probably, if you do it properly, you will end up with a decent system which performs very well. And that is the main goal of this video. I want to show you how to properly design your RAG system. So I will start by the 3 techniques that we discussed in RAG-GPT, and I want to expand it to 5 techniques and start a contest between them. And then at the end, we will see metrics such as inference time, overall performance, document-based performance, since we are going to put them in challenging scenarios and see how they perform on various type of documents. And at the end, I will also give you 2 different chatbots that will provide you with 8 different RAG techniques that you can test on your documents and evaluate their performance. So let me quickly show you a demo of our 2 chatbots. These are the 2 chatbots that we will have by the end of this video. And on the left, you can see the chatbot for Llama-Index, and on the right, you can see the chatbot for Langchain. And I mentioned that they will give you 8 different options to choose from. So let's see what they are. If you go into the setting of Llama-Index, you will see a bar called Select the RAG Technique. And if you check it, you will see 4 options are available here: Page-wise RAG, Basic RAG, Sentence Retrieval, and Auto-Merging Retrieval. I will explain each of these techniques later in the video, but I just want to mention that for Llama-Index representatives in our contest, we will have Sentence Retrieval and Auto-Merging Retrieval. So if you check the setting of Langchain, you will see 2 different options here. On top, you will see the retrieval technique selection that you can choose from, and we have MMR search and similarity search. And on the bottom, we have the splitter technique, which is from the chunking side, and we will have token splitter and recursive character splitter. So combined together, you will have 4 options from Langchain and 4 options from Llama-Index, and overall, you will have access to 8 RAG techniques using these 2 chatbots. So let's also quickly see a demo of these chatbots and how they perform. So let me choose sentence retrieval from Langchain, and also let me go with MMR and recursive character splitter, for example. I will also show you the documents that I'm going to use for testing these RAG techniques. But one of the documents contains a few fictional stories, and one of the stories is about a character called Fred. So let me quickly ask who is Fred from both of our chatbots and get the answer. So Fred is a small fish who lived in a cozy coral reef with his loving family. And on this side, we have Fred is a small red fish who lived in a cozy coral reef with his loving family. So we have the answers from both techniques. Just to clarify, I'm using GPT 3.5 for my large language model, and I'm also using OpenAI embedding model in the backend. So the performance might change based on the large language model that you're using and the embedding model that you will use in the backend. I will also use GPT 3.5 for the test and evaluation pipeline. So now let me quickly explain those 8 different techniques that we just saw. Since I explained all these techniques in RAG-GPT, I will just do a quick recap on them so you can catch up and we can move on and see our pipeline. So with Llama-Index, I talked about sentence retrieval, and you can see the image right now. In this technique, let's say that I have a document and I chunk the document for simplicity, let's say based on each sentence. And for the answer to my question, the orange line was retrieved from the vector database. So right now, instead of just passing that orange line to the large language model, I will add a few sentences before that orange line and a few sentences after that line. So eventually we are going to pass the whole gray area, the whole paragraph, to the large language model. This is called sentence retrieval. We also talked about auto-merging retrieval. So in auto-merging retrieval, we start chunking the document and we call each chunk a parent node. And then we again start to chunk each one of those chunks to smaller chunks, of course, and we are going to call them child nodes. So two scenarios can happen here. The first scenario is, let's say to my question, child node 1 was retrieved from the vector database. So in that scenario, nothing has happened. We are just going to pass it to the large language models, and in general, you are going to retrieve multiple chunks from a vector database. So in our case, child node 1 was the only selected node from this parent node. Scenario 2, I ask a question, child node 1, child node 3, and child node 4 are retrieved from the vector database. So here, it makes sense if I also add child node 2 and pass the whole parent node to my large language model. There is a great chance that that missing node, which I didn't retrieve it from my vector database, would add context and would provide my language model with a better explanation, and therefore my language model will be able to give us a better answer for that question. So these are sentence retrieval and auto-merging retrieval. But in the chatbot, we also saw basic RAG and we also saw page-wise RAG. So what do I mean by them? Basic RAG is if you copy-paste the whole document into your chatbot, or let's say to your GPT model, and ask a question about it. So most probably, the main challenge that you would have is the context length. So you cannot just use this technique for all your documents, and that is why we even need that chunking strategy, because we have limitation with regard to the context length. But that is what Llama-Index called basic RAG. And then we also have page-wise RAG. So page-wise means you simply divide your document based on each page. So there is no strategy involved in the chunking side, and you do the normal search. So you ask a question, your question is going to be searched on the vector database. Some chunks, or in our case, some pages will be retrieved, and those pages will be passed to the large language model. That is a great baseline for your evaluation. So I also provided to you in the chatbot. And we also have the Langchain techniques. So in Langchain, there are two main things that you can do for preparing and designing your RAG system. First is the chunking strategy, and Langchain is providing you with a ton of options. So you can choose different chunking strategies such as token splitter, a text splitter, recursive character splitter, and so many others. And on the retrieval side, you also have options such as MMR search or similarity search. To make it a fair contest, I wanted to both have different strategies for chunking and also different strategies for retrieval side of a document. So that is why I selected 3 different strategies from Langchain and the 2 main strategies from Llama-Index, and I'm going to put them into test. So just a quick note, what are the other options out there that you can choose and design your RAG system with? There are so many different options. So for example, if you're already using a cloud environment such as Google Cloud, Microsoft Azure, and AWS, each one of those frameworks are giving you different options for designing your RAG system. So one of the things that you will notice is both Google Cloud, for example, and Microsoft Azure have already adopted Langchain. So that is a great choice for you. But beside that, they also have their own built-in techniques, and you can choose different strategies. Also, there are other techniques like FAISS, if I pronounce it correctly. So it's called FAISS. It is coming from Meta, and that's just another option for you. And on the other side, you also have Hugging Face as well. And I just recently saw that ChromaDB is providing their RAG strategies. I'm not sure how that one works, but the whole point is you have a lot of options. But these 2 frameworks are just the ones that I've seen that are becoming more popular, and more companies are adopting them. And based on my experience, they work very well. So theory is enough. Let's find out who is the RAG master. I want to show you the pipeline in 7 different steps. Let's begin by the first step, which is the documents that we want to use for our evaluation. These are the 5 documents that I selected for this pipeline. So if you have watched the previous video, which I explained fine-tuning of a large language model on a company dataset, you know that I created a fictional company called Cube Triangle, and for that company, I generated fictional documents. So document 1 is product catalog of Cube Triangle, which contains product names along with their features. And in the second document, we have just customer support Q&A of Cube Triangle. So it just contains questions and answers that I tried to replicate for a customer support scenario. Then we have our third document, which is the one that I asked the question in the chatbot demo. It contains 3 different stories for Amarok the lone wolf, Fred the redfish, and Lily the bee. So this is the document that is going to represent a simple PDF, let's say a simple novel, a book that we might have. And finally, I have 2 technical papers. The first paper is a very famous paper from Google, and it is for Vision Transformer. I chose these 2 because first, they are technical papers, and I wanted to see how our RAG system would perform on them. And second, I chose this one as a 1-column technical paper, and I chose segment anything paper to represent the 2 columns technical papers. All right then, I started to chunk these documents, and I passed them to ChatGPT, and each time I asked ChatGPT to give me some questions along with their answers. So these are the questions and the answers that I created from these 5 documents. So we have 40 questions overall. So the index starts from 2 to 41. For example, for stories, we have 5 questions. And for technical papers, we have more because I just wanted to put the RAG systems into a more challenging situation. And for each question, I also got the answer. So you can see the correct answer here. And then we are going to start passing these questions to each of the techniques, and we are going to collect a bunch of information. But for now, let me explain what was the mindset behind these questions. So I tried to have a range of questions from very simple ones to challenging ones. So a simple question would be, who is Fred? The question that we just asked from the chatbots. But a challenging question would be a question that is coming from a few chunks, but it is a hybrid question, let's say. So let me give you an example. So if you check this question right here, this one, you can see that it is asking what modifications are made to the baseline ResNet model for the hybrid variant, and how does the hybrid model feed intermediate features map into a Vision Transformer. So VIT is the key that the RAG systems should be able to catch. However, that question is followed by a second question. Additionally, how does the sequence length impact the computational cost of the hybrid model? With RAG systems, the more accurate and the more precise is your question, the better will be the answer that you are going to get from your RAG system. But in general, when you are designing the RAG system, you want to push the limits and extend the boundaries a little bit just to make sure that your system is going to address all the expectations of your users. So we just saw the documents, and I showed you how I prepared the questions. One note is, unlike many other machine learning tasks that we have a metric that we can train our model with that metric, or we can evaluate our model. When you design a RAG test pipeline, you should know that there is no unique metric that you can fully rely on. And throughout the whole process of designing and having that pipeline, you need human judgment. So just make sure to double check every single step that you are generating something or you are scoring something, because that's a crucial aspect. So for the next step, we want to set up the project, the Python project, and set up the Python environments. So let me show you what is that step. So since I want to compare Llama-Index techniques with Langchain techniques, and each one of those frameworks has its own dependencies, and unfortunately, their dependencies have conflicts with each other. I couldn't use one single Python environment. So if you check the project, you will see Langchain env requirements.txt and Llama-Index env requirements.txt. So these are the two files that enables you to set up and install the libraries and dependencies for each environment. And unfortunately, throughout the process, we have to switch back and forth between these two environments and go through the whole pipeline. So that is one note. And on the other side, for the project structure itself, again, I'm using the same structure as I used in the previous videos of this series. In config folder, I have config.yaml, which contains all my arguments and the configs that we can use for different techniques. Then we have Llama-Index configs. So you can see 4 different techniques here: basic RAG, page-wise RAG, sentence retrieval, and auto-merging retrieval. And also on the Langchain side, you have the chunk size, the chunk overlap, and the number of documents, again, that will be retrieved and passed to the large language model using our approach. And at last, the temperature. So again, just like before, for RAG system, I tend to have temperature equal to 0 because I just want the most accurate, precise answer from the model, and I don't want the model to be creative by itself. These techniques, when you implement them, you have to spend some time and iterate over them and try different configs and see which one would suit your documents the most. Then we have the data folder, and here I keep the raw data, the documents that I showed you. We have the eval questions, the Excel file that we are going to use to pass to each one of those 5 techniques and get the results from them. We have the indexes. This is where our vector databases will be stored for each technique. And then we have the source folder, which contains all our codes. So again, since I had to separate Langchain from Llama-Index because of their dependencies, you see 2 folders, one for Langchain and one for Llama-Index. And the Langchain folder contains the chatbot that works with Langchain, and also the module that prepares the vector databases for the Langchain. And the same goes for Llama-Index. I have the chatbot that works with Llama-Index, and I have the module that prepares the vector databases for our Llama-Index techniques. And you have the README file. So I have provided you a detailed explanation in the README file of the techniques that I'm using, and also the order that you can execute the codes to make the whole pipeline work without any issue. So as you can see, we start by installing and preparing the environments, which I already have them, so I skip these 2 steps. But the next step is to prepare the vector database. So for Llama-Index, you see that there is a module here called prepareindexes.py. If you go into the module, you will see that I have a function that will be called at the end of the module. And in that function, I am defining the large language model and the embedding model that I want to use for my Llama-Index in general. Then I create the service context, and I also set the global service context. So one keynote is I use the codes from the exact tutorials that Llama-Index published a couple of weeks ago. Then I load the documents. When I load the documents, my documents will be loaded in pages. So the output will contain a list, and that list contains different pages as its elements. So that is why I called it page separated documents. Then I go through 4 different techniques, and I create the vector database for each one of them, and I store the vector database in data and indexes folder. So we have 4 different techniques: page-wise, basic RAG, sentence retrieval, and auto-merging retrieval. So we are going to use different structure of our documents for these techniques. Let me just explain that to you, and the rest is simple. So I get the page separated documents. That's one. For basic RAG, I combine everything together, all the pages together. Then we have page-wise RAG index. So to create page-wise RAG index, I exactly need this argument here, page separated documents, I pass it to my vector store index from document that we just loaded, and we have the index here, and I just need to store the index in my local folder. Then I have sentence retrieval index. The way that Llama-Index tutorial showed is that they are passing the merged documents, so the one that we created here. So we get the list that contains all the pages. We combine all the pages into one big element, let's say one long page, and we pass that one long page to build sentence window index. And you pass the embedding model, you pass the direction where you want your index to be stored, and the window size. So the window size is right now, if you check sentence retrieval, the window size is 3, and that is the number of sentences that you will add to the retrieved sentence from the search result. Then we have the auto-merging retrieval index. For this one, in the tutorial, they are passing the page separated documents. We are going to pass the output for creating the auto-merging index. You pass the large language model, the embedding model, where you want to store the index, and also the chunk size. So one thing to keep in mind, since we have the parent node and the child nodes, it is not just simply an integer, but it is a list of integers. So you can see 3 values here that you can play around, you can change it, and you can see the difference in the performance of auto-merging retrieval technique. So that is it. And you can see that I'm also using some functions. So these functions are just simply the way that I'm loading my language model, my embedding model, and also the way that Llama-Index itself provides the service context for sentence window index and also auto-merging index. They provided their own functions, and I'm using the exact functions that they provided us. You also can see 2 more functions, which is get sentence window query engine and also get auto-merging query engine. So after you store your indexes for Llama-Index, and when you want to start searching over the indexes and find and retrieve the documents, these are the 2 functions that you use for these 2 techniques. So this was the prepare indexes.py for Llama-Index. And if you check in the README file, you will see this code here, Python source Llama-Index prepare indexes. If I run this code, you will see how those indexes will be created. Of course, I have to change my environment. Here it is. So processing the documents and creating the index for basic RAG, processing the documents and creating the index for page-wise RAG, for sentence retrieval, and for auto-merging retrieval. And also you will see when the index was created and stored on your local machine. So I just ran the vector database preparation command for Llama-Index. Let's see the same step, but for Langchain. So for Langchain, if you go in Langchain folder, you will see prepare vector database.py. I am using the exact same code that I used in the previous projects in WebRAG query and in RAG-GPT. So if you have, again, watched those videos, it should be very easy for you to understand what is happening here. But the way that I did it initially was I created this top module that calls out a class called prepare vector database. And if you go into that class, you will see that I have defined 2 different techniques. One is recursive and the other one is token. So these are the 2 techniques that I'm going to use for chunking my documents and storing them in the vector database. And then you will see the functions step by step. Load all the documents, chunk documents, prepare and save vector database, and that's it. So what you have to do is you set the config in your config file, and as you can see for Langchain, you have 2 options. Either it is recursive or it is the token splitter that you want to use. Check the README file, take the code for Langchain, go to Langchain environment, we see that it is preparing the vector database for the token splitter. Number of documents is 5, total number of pages 67, number of chunks 185. We created the vector database and we have 185 vectors in it. And as you can see, I just have the Langchain token index file added to my index folder. So let's also add the same pipeline for the recursive type. So I just changed it in the config. I run the code again. Let's see this one. Splitter type is recursive, loading documents manually, and then I have 5 documents, number of pages again 67, number of chunks this time 262, and number of vectors in vector database is 262. So vector databases are ready. The next step is to get the answer from each technique for all of our questions. In source, you will see a folder called Evaluate RAG Techniques. So if you go to Evaluate RAG Techniques, you see 2 modules. One is called Run Langchain and the other one is called Run Llama-Index. These are the 2 modules that we are going to use to take each technique, run it through the whole list of questions and get each answer, save it on our Excel file. Beside that, I also want to collect the inference time for each question. So if I go into Run Langchain, you will see that I'm calling my embedding model, my large language model. I have 2 vector databases, again, depending on which one is activated in our config folder. And then I also have to define the search type for getting the answers. So our search types for Langchain are MMR and similarity search. Again, you can define it in the config folder. Let me bring it here. So if you check here, you will see there are 2 options for the search type, either MMR or similarity search. Each one of them has its pros and cons, so you have to test and you have to find out which one works better for you. But out of those 4 combinations, I just want to go through 3 of them. I will consider MMR for both token splitter and recursive character splitter vector databases. I will also consider similarity search for recursive character splitter. So you set your config here, and all you have to do is, if you check your README file, you will see, so I will skip these 2 lines for now. Since you have your vector database ready, you can also start chatting immediately with your chatbots. So chatbots are separate from the testing pipeline. But if you go through this code, Python source, evaluate RAG techniques, run Langchain, you will see I have my system role here. You're a chatbot. You will receive a prompt that includes retrieved content from the vector database based on the user's question and the source. Your task is to respond to the user's new question using the information from the vector database without relying on your own knowledge. So that is one of the key steps in designing a RAG system. You don't want your large language model to use its own knowledge because there is a chance that it hallucinates. I prepare the messages for the input of my model. I prepare the prompt, which is going to be just the message wrapped in chat prompt template. I have the chain type. I have my chain created here. Then I load my Excel file. I go through the Excel file line by line. I extract the question. I pass the question to my RAG pipeline. I get the answer. And in the question data frame, which I just created, I add the answer for that specific row. And I also add the inference time. So these are the 2 things that I'm going to collect at this phase of the pipeline. So if I go into my Langchain environment, and if I go into my README file, and I execute the code, you are going to see how that works. So these are the questions one by one. You can see the question. Let me stop at one of them. Question number 3. This is the question. This is the answer that was given to me by MMR search type, and from the recursive splitter type vector database. So this is the combination that I have right now on my config file. And it goes through all of the questions, and it is going to save the data frame at the end. We have our data frame ready. So I will run the pipeline for the other two methods of Langchain, and I will see you when I want to run the pipeline for Llama-Index so I can explain what is happening, and then we can execute the code together. My Langchain results are ready. Let's also prepare the results from Llama-Index. For Llama-Index, you see the module called Run Llama-Index in Evaluate RAG Techniques. If we go through the code again, we are doing the exact same things, but with Llama-Index codes. So we defined the large language model, which is the same GPT 3.5 as we used, the same embedding model as we used. We set all the steps that are needed, and we also set the evaluation method. So this time we also need to evaluate each method separately. For example, if you set it to sentence retrieval, it will only go through sentence retrieval. And if you set it to auto-merging retrieval, it will only go through auto-merging retrieval. Then I point to the correct vector database. I create the query engine for the selected technique, and I go through the Excel file, take each row, pass it to the RAG pipeline, get the answer, and also get the inference time, and save it into my Excel file. So let me first activate my Llama-Index environment. Here we go. And if I go into my README file, Python evaluate RAG techniques, run Llama-Index. So right now it's going to run it for sentence retrieval. So we have the first question, the second question, and so on. I ran the code on all of the techniques, and I collected all the results that I wanted. So in this step, you can take those answers along with the question and the correct answer and pass it to a powerful large language model and ask that large language model to score it for you. So in our case, I want to use a GPT 3.5 for this purpose, but the more powerful your model is, the better would be the scoring. So probably if you can use GPT-4, for example, that would be even a better choice. So I have a module here called Run GPT Eval. And in the README file, you can also see there is one last command to execute. In this code, we have one thing to think about. And that is, how do we want to start passing those results to the large language model? Let me give you an example. One way is to get the question, get the correct answer, and add all the results from all 5 techniques and pass it to a large language model. Well, you might think that in that case, the large language model can see the results from all the techniques and probably it can give them a better score. But there is one downside to that. There is a great chance that you can hit the context length limit, or even if you don't hit that limit, you're going to overwhelm your large language model, and instead of benefiting from seeing all the results at the same time, it might suffer from that technique. So let me show you the approach that I'm using here. In this code, you can see there is an argument called pack, and on top, I added a comment that shows what are the values that it can take. So I divided our 5 techniques into 3 different groups. Our first group is Langchain token MMR alone. So I will pass this technique by itself. And for the system role, I'm using almost an identical instruction for all 3. So it says score each given answer from 0 to 1. 0 means it is wrong. 1 means it is a complete answer. It includes all the key information, and list them with system names like this. So for instance, in case our pack is equal to Langchain token MMR, it is going to give me Langchain token MMR and the score that our large language model wants to give to that answer. And for instance, for the second group, which is Langchain recursive, I'm passing both the similarity and the MMR results together. And in this case, I just asked the model to give me the result in this style. And for the last group, I will pass Llama-Index results together, sentence retrieval and auto-merging retrieval, and I'm asking the model to give me the results in this form. And the reason behind that is I want to be able to extract the results automatically and add them to our Excel file. So this is where I'm doing it, again, depending on what technique you are passing at the moment. So depending on the value of pack, it is going to collect the question, the correct answer, along with the corresponding answer of that technique, create the messages, pass it to the GPT model, get the results, extract the results, and save the results into our Excel file. So let me show you one of them, and then I will execute the rest. We can see that it will start giving us the score for each question for Langchain token MMR. And I'm collecting each one of them and adding them to the Excel file. So that's it for Langchain token MMR. I will execute the code 2 more times for the other 2 groups, and I will see you after I have collected all the scores for our techniques. I collected all the results from our techniques in the Excel file, and as you can see, I already opened the notebook called Result Analysis, and I want to start evaluating those techniques from different perspectives. I also opened both of our chatbots. I will also start passing some of the prompts that we will see throughout the analysis to see the results in real time, also in the chatbots. And also I will include the table on the screen, and I will start filling it in while we are going through the analysis. So in the first cell, I'm just importing some of the libraries that I want to use for the analysis. Then I'm importing the Excel file into a data frame. I'm also checking to make sure that there are no NaN values in our data frame. I'm also printing the columns, and as you can see, I have the inference time, the results, and also the scores that we just received from the GPT model. And in the first step, I want to find out the score of each technique on our 40 questions. So in this evaluation, the maximum score that each one of the techniques could achieve is 40, obviously because of the number of our questions. And let's see how they performed. So Langchain token MMR technique got 36.1. Langchain recursive similarity got 38.4, which I can see that it was the best technique overall. For Langchain recursive MMR, we have 35.95. For sentence retrieval, we have 36.6, which is the second best technique. And for auto-merging retrieval, we have 32.3. So that is a very interesting result, because when you think about the concept behind each one of those techniques, probably auto-merging retrieval has the most complex concept behind it. But as we can see here, it is actually the worst. And the best scorer is recursive character splitter for the chunk side and similarity search for the retrieval side. So now imagine that I have passed a question to all our 5 techniques. There is a chance that more than one technique be among the best scorers. Let's say for a specific question, the best score is 1, but 2 of our techniques got 1 for that question. Or the opposite. For example, I have passed a question and more than one technique were among the lowest scorer. So this is what I'm going to count here. The number of times that each technique appeared to be among the best scorers, or the number of times that each technique appeared to be among the lowest scorers. So if we start counting, we can see that Langchain recursive similarity was 36 times among the best scorers. Llama-Index sentence retrieval was 34 times. Langchain recursive with MMR, 33. Langchain token MMR, 33. And Llama-Index auto-merging retrieval, 23. So again, Langchain with recursive character splitter and the similarity search appeared among the best scorers more than the others. It got the score of 36. And the last scorer is auto-merging retrieval. And if I count the ones that appeared on the bottom, we can see that rank number 1 is auto-merging retrieval, so it appeared to be on the bottom much more than the other ones. We have Langchain token MMR, which is the second worst performer, let's say, but there is a huge difference here, right? So if we check the best one, again, it is 36, 34, and 33, which are very close together. So in the next step, I want to start counting the number of times that each technique got a 0 score for a question. So Langchain token MMR was totally wrong about 2 questions. Langchain recursive similarity was wrong about 1 question. Langchain recursive MMR missed 2 questions. Llama-Index sentence retrieval missed 1 question. And auto-merging retrieval missed 3 questions. In the next step, I want to start analyzing the result based on each document. So for the first metric, I want to evaluate the score of each technique on each document. So let's see. So on segment anything paper, the best scorer was Langchain recursive similarity with 13.6. And the second best scorer was Langchain token MMR with the score of 13.3. For product specification, the best scorer was sentence retrieval with 4.5. And the next best scorers are auto-merging retrieval and Langchain recursive similarity. Both of them got the score of 4. For the stories, our best scorer is Langchain recursive similarity with the score of 5. And the second best scorer is Langchain recursive MMR with 4.75. For technical support, we have 4 different techniques among the best performers. So the only technique that couldn't properly perform on that document was sentence retrieval, which is ironic because we have seen that it was closely chasing Langchain recursive similarity technique. And this to me is our easiest document because it contains questions and answers. So as soon as they get a chunk, they should properly retrieve the exact same answer for that question. And for Vision Transformer paper, our best scorer is recursive MMR, and the second best scorer is recursive with similarity. So that is interesting. I wanted to show you this result because it is very important what type of documents you are using. Based on the type of your document, there might be a different technique out there that can outperform the other techniques. So as I explained in the video, I chose these documents for different purposes, and now we can see why. The average score per document. Now let's focus on each document, and this result is normalized. Segment anything paper got 0.9, product specification got 0.74, stories got 0.88, technical support 0.97, and Vision Transformer 0.94. So exactly as I expected, technical support was the easiest document for our techniques, and the hardest document was product specification with the lowest score. And the last takeaway is our techniques had a decent performance on our technical papers. This is just one of the things that I personally wanted to see, and I wanted to also share it with you. So now it is time to analyze our techniques based on the inference time. So let's see the overall time that each technique took to answer to all 40 questions. Langchain token MMR took 68.97. Langchain recursive MMR took 62, almost 62. Langchain recursive similarity 66. Sentence retrieval 100.95, and auto-merging retrieval 52.66. So as we can see, Langchain techniques have almost the same performance speed, but the slowest technique is sentence retrieval with a huge margin, something around 30 seconds more. And the fastest technique is auto-merging retrieval with a huge margin with 52 seconds, which is at least 10 seconds faster than the other ones. As you can see, depending on how fast do you want your technique to perform, you might want to choose a different technique. Overall, Langchain techniques, in my opinion, have a decent speed. They are not the fastest, but when you take into account the accuracy and also the speed, Langchain is giving us nice options. And also the average inference time. So it is the average time that each technique took to answer each one of our questions. Langchain token MMR took 1.72, Langchain recursive MMR took 1.55, Langchain recursive similarity took 1.67, sentence retrieval 2.52, and auto-merging retrieval 1.3. So here I want to go through each technique and see what were those questions that they missed. They got 0 score. So for auto-merging retrieval, the questions that technique couldn't find are: who are Amarok, Fred, and Lily? That is interesting because that document, I assume it is an easy one, but apparently it was not for auto-merging retrieval. So when I think about this question, the challenging part about this one is that document, the stories document, contains 3 pages, and each page contains a different story. So I'm asking about the 3 characters in those stories, and our technique should have been able to retrieve all 3 pages to give us an answer. And apparently auto-merging retrieval failed to do that. And you can see that the answer is there is no information provided in the given context about Amarok, Fred, and Lily, which is totally wrong. Let me also open the full response. So the second question was, how much does one of our products in Cube Triangle cost? The correct answer was $2,000, and the given answer was $800, which is wrong. And how was the data engine used to collect the SA 1 billion mass dataset, and what were the 3 stages of the data collection process? And the given answer was the data engine was used to collect the SA 1 billion mass dataset fully automatically. The 3 stages of the data collection process were not explicitly mentioned in the given context. Again, that is a wrong answer. So let's also see the performance in our Llama-Index chatbot. This is our Llama-Index chatbot. I want to keep it here. Let me choose auto-merging retrieval, and let's pass the first question. There is no information provided in the context about Amarok, Fred, and Lily. So we can see that this model is failing to provide us with the proper answer. If I switch the technique to, let's use page-wise RAG, since this is the technique that I suggested as a baseline. And if we ask the same question, Amarok is a lone wolf, Fred is a small red fish, and there is no mention of Lily. At least page-wise RAG was able to give us 2 out of 3. Let's go with sentence retrieval, the same question. Amarok is a lone wolf, Lily is a young bee, and Fred is a small red fish. So this is the correct answer to that question. All right, so let's continue and see the performance of the other models. So for the next one, I have Llama-Index sentence retrieval, and this model only missed 1 question, which is how was the data engine used to collect the SA 1 billion mass dataset, and what were the 3 stages of the data collection process? The given answer is the context does not provide information about how the data engine was used. So that is clearly wrong. Let's also test it again. So I'm already on sentence retrieval, and if I pass this question, the context does not provide information, which we know that is not the case. So let me go with page-wise RAG and ask the same question. The data engine, so I don't know the exact answer, but it was able to give us an answer for that. So that is, again, interesting. Page-wise RAG is probably the easiest technique that you can apply, and always apply it and keep it as a baseline. Let's go with auto-merging retrieval. And as we saw it earlier, auto-merging retrieval also struggles with this question. So let's move on to the next technique, which is Langchain token MMR. So for this technique, there are 2 questions that it missed. How much does Cube Triangle speaker cost? And is there any skateboard with 20 mile per hour top speed with 15 mile range on a single charge? So that is one of the products that actually Cube Triangle has, and this model could not find anything about it. So let me first pass this question, for example, to one of the Llama-Index techniques, and then I will pass it to the Langchain ones. So let's go with auto-merging retrieval. yes, there is a skateboard with a 20 mile per hour top speed and 15-mile range on a single charge. So that is correct. There is such a product. And if I go to Langchain chatbot and I ask the same question from token MMR, so token splitter with MMR search, let's ask the same question. I'm sorry, I couldn't find any information. Well, we just saw that it fails. Let me switch it to recursive character splitter for the chunking side. It also cannot answer the question, so I assume we are going to see the same question when we analyze that technique. Let's go with similarity search and recursive character splitter technique. Yes, there is such a product in cube triangle. So we also saw some of the questions that Langchain techniques might fail, and let's continue to the next technique. So here I have Langchain recursive MMR, and I have the same question that asks about the cost of a product. Most of our models struggled with this question. And is there a skateboard? We just saw that it fails with this technique as well, and this is the exact same question. So let's go to the next technique, which is Langchain recursive similarity. So we can see that it is failing with this question about the cost, and that is the only question that it failed. So if I ask the question about who are Amarok, Fred, and Lily from Langchain techniques, I should see the answer. Let's see. Who are Amarok, Lily, and Fred? Amarok is a lone wolf. Lily is who got separated from her family during a storm. So it is giving the story of Lily and what she went through, and Fred is a small red fish. That is the correct answer. So let's also switch to a different technique, MMR with token splitter, same question. Amarok is a lone wolf, Lily is a small bee, and Fred is a small red fish. Again, this technique was also able to get us the right answer for that question. So again, with these two chatbots, you have 8 different options that you can explore and you can experiment. And these two chatbots can give you a very good idea on probably what are the best techniques that you can start your RAG project with them. All right, so let's move on to the next step, which is the last analysis that I want to do on our techniques. And here I want to plot an image. Let me plot it and explain what is this image. So on the y-axis, we have the scores. And as we can see, Langchain recursive similarity was the best scorer overall, and auto-merging retrieval was the worst scorer among our 5 techniques. And the size of the circle shows the number of times that each technique appeared on the top. So again, as you can see, these 4 are very similar. As you remember, Langchain recursive similarity appeared on the top 36 times. Langchain recursive MMR appeared on the top 33 times, and also 33 times was the same result for Langchain token MMR. And for sentence retrieval, we had 34 appearance. So that was it. And right now with RAG GPT video and this video, you have both sides of how to design a chatbot and also how to evaluate a chatbot. And in this video, we also saw some of the best techniques that you can start designing your chatbots with them. Just don't forget to start iterating over different techniques with different configs and optimizing your chatbots. So thank you very much for watching the video, and I will see you in the next one.